Alright guys, we have today's lesson here, solving linear inequalities. Okay, let's begin by defining what an inequality is. An inequality compares two values showing one is, and then we have four options here, one is less than the other value, greater than the other value, less than or equal to the other value, or greater than or equal to the other value. Notice we have four symbols here, the less than, greater than, and then the same symbols but with a little bar underneath. It's one of the equal sign bars. So this one could be one of the two. It could either be less than or equal to, and this one could be greater than or equal to. Notice how the greater than symbols use the same arrow there. Okay, it's pointing in the same direction. It just has a little bar underneath. Okay, so let's begin with some examples and then we're going to be graphing them as well. First one, solve 5x minus 7 is less than or equal to negative 32. So what we're saying is that the left side here is going to be less than or equal to this side. Alright, so we're going to go ahead and solve for x just like we were doing with equations. Remember, equations are the ones that have an equal sign. So this is not an equation, this is an inequality. We're going to solve it the same way. So we're going to go ahead and add 7. We're going to undo what they do. Okay, and so that cancels there. We are left with 5x is less than or equal to, and then you just subtract negative 32 plus 7. That's going to be 25. Okay, I have a calculator if you wish. It'll be 32 minus 7. I know I'm subtracting. So I get 25. But notice here the 32 is the bigger or the larger number, so we keep the negative sign, okay? So now we're going to go ahead and divide by 5. The 5's divide out there. We're left with x is less than or equal to, now 25 divided by 5. Use the calculator. Just go ahead and 25 divided by 5 is 5. Okay? You are allowed to use the calculator to calculate division, okay, or any other operation. So since we have a negative divided by a positive, we write a negative there. Now let's graph this then. What this is saying that in order for this side here to be less than or equal to negative 32, we need to find all values of x that are less than or equal to negative 5. So what I like to do is I just like to go draw a blank number line, and I just draw a little tick mark right at the center. At the center, I'm going to write this number here, negative 5. Okay? And if you want, you could draw tick marks to the right. I usually don't. But those little tick marks indicate the next whole number. Okay? So we have negative 4 this way, negative 3, negative 2, negative 1, and 0, and then 1, and then 2, 3, 4, and so forth. Over here we have negative 6, negative 7, negative 8, negative 9, negative 10, and so on. Okay? Like I said, I only like writing the one that we're using, the negative 5. So what I'm going to do here is I'm going to circle this. That means it doesn't include the negative 5, okay? But if the little inequality has a little bar underneath, we're going to shade that circle in. Okay? Now that means that it could be equal to the number that it's above, okay? And so it's above negative 5. So that means this can be negative 5. Now, all the values that are less than negative 5 are going to be the negative 6, negative 7, negative 8, negative 9, negative 10, and so forth, and all the numbers in between. So we're going to just go ahead and draw a squiggly line to the left, and that's my graph. Okay? The first example is always the most difficult to understand, so let's just keep doing some more. Okay? Again, let's solve here for x. So we're going to go ahead and subtract 10. So we're left with 3x is less than or equal to, and now negative 10 and negative 2 make negative 12. Okay? I have two negatives, so I'm going to add them, and I get 10 plus 2 is 12, so negative 12. Now let's divide by 3. So I get x is less than or equal to, now what's negative 12 divided by 3? Negative 4. Okay, let me go ahead and draw my graph right here. Again, it's just a blank number line. Go ahead and put -4 at the center. You don't need to write the tick marks to the right or left. And let's always circle it. Always circle it, okay? Now, we have to determine whether we need to shade it. If it has a little bar underneath, that refers to or equal to. So yes, since it has an or equal to bar, we're going to shade it in. If it didn't have it, then we would leave it open. Okay, now notice here this says x has to be less than or equal to -4. So all the values that are less than are going to be to the left. So just shade to the left. The right side remains unshaded. Okay, another one. Let's go ahead and subtract 14 here. So we end up with 3x is greater than or equal to. Now let's do this here. 29 minus 14, that's going to be 15. Okay? So notice again, I subtracted 29 minus 14 is 15. Next step, divide by 3. I get x is greater than or equal to, and now what's 15 divided by 3? It's 5. Okay? So let's draw a blank graph. What number do we put in the middle tick mark there? That's right, 5. Put an open circle. Okay? Again, we're going to shade the open circle because it has the or equal to. So notice here now we're looking for all the values of x that are greater than or equal to 5. So greater than would be on the right side. So we just shade to the right. And that's it. That's my answer. Okay? Now, these are all special cases. You'll see why in a moment, okay? So what we're going to do here is we're going to do the same thing. We're going to start off by subtracting 31. And notice here, this time my variable here has a negative next to it. Negative 2x is less than, now 19 minus 31. Let's do that. 19 minus 31 is 12, or in this case, negative 12. Okay, again, remember the 31 is larger and it's negative, so that's why we keep the sign negative here. We just subtracted the 2. 31 minus 19 is 12, and since the 31 is a larger number, we're going to go ahead and put the negative in our answer. Okay, but notice here what we need to do here is divide by -2 on both sides. Whenever you divide by a negative, you must switch the direction of the inequality. Okay, so since we're dividing by a negative here, it's going to be x is greater than, and then whatever we get here. Negative 12 divided by -2, that's going to be a positive 6. Okay? So, again, we divided by a negative number. It makes no difference whether the other number here that was by itself is negative or not. It makes no difference. If we divide by a negative here, we must switch the direction. So notice here, it was less than, but now we have to make it greater than because we divided by a negative, okay? So when I graph my answer, I'm going to put the 6 right in the middle. I'm going to put an open circle. And now notice here, this does not have the bar underneath, so I'm going to leave it open. And then I'm going to shade to the right because this says x is greater than 6. So all the numbers that are greater than 6 go to the right. Okay? Now, you may be wondering, why must we switch the direction of the symbol? So the reason we do that is to keep the statement true. Let me give you guys a quick example here off to the side. Okay? So say for example we had 2x is greater than 10, and over here negative 2x is greater than 10. Okay? To solve this, we would just simply divide by 2. We get x is greater than 5. In other words, if you were to plug in a number bigger than 5 here, it could even be 5.1. Okay? If we were to plug in a number greater than 5, we would have a true statement. For example, 2 times 5 is 10, and 10 is not greater than 10, so we cannot plug in the 5. We have to plug in a number that is greater than 5. So let's say, for example, 6. 2 times 6 is 12. Is 12 bigger than 10? Yes, it is. But watch what happens when we do it here. If we divide by -2 on both sides and we don't switch direction, Watch what happens. If we don't switch the direction, we keep it the same way. Notice here, it says here you could plug in a number that is greater than -5. Now remember, for negative numbers, a number that is greater than -5 can be a negative number also. It could be -4 or -3 or -2. It could even be 0. So for example, let's plug in a 0 here. -2 times 0 is 0. Is 0 bigger than 10? No, it's not. So that's why we have to switch the sign in order to keep it true. For example, if I plug in here now a value that is less than -5, a value that is less than -5 would be like -6 or -7, -8, and so on. So it'll be all the numbers to the left of -5. So for example, let's try -6. -2 times -6 is +12. Is +12 bigger than 10? Yes, it is. And that's why we have to switch the direction whenever we divide by a negative in order to keep the statement true. Okay, so let's finish these off here. So let's go ahead here and add 5. The 5's cancel. I'm left with -7x is less than negative. Now what's 61 minus 5? That's going to be 56. Okay, so it's going to be divided by -7 on both sides. Notice we are dividing by a negative again, so what must we do? We need to switch the direction. So negative divided by negative is going to be a positive, so 56 divided by 7 is 8. Go ahead and draw your graph here. Put just a single tick mark there, put the 8 there, and then put an open circle. Don't shade it in, and then just shade to the right of that because the symbol was greater than. Last one, and then we're done. Let's go ahead and subtract 69 on both sides. -2x is greater than, now let's subtract here. Let's do 81 minus 69. That's 12. +12. Okay. Again, divided by a -2. I get x is, switch the sign, less than -6. Okay, again, I divided by a negative. So it's going to be 12 divided by -2 is going to be a -6. But remember, I needed to switch the direction of the inequality because I divided by a negative. So write your little tick mark there, put a -6 there, open circle. Do we shade it in? No, we don't. And now the symbol is less than, so we have to go all the values to the left. And that's it.